Now let's look at the mistakes people make with recursion and how to avoid them. This is the most common recursion bug, a base case that is never reached. Here is a buggy factorial. The base case checks whether n is equal to 1. That looks fine at first. But the recursive call always uses n-1. Call this with a valid input like 0. Then n counts 0, -1, -2, and so on. It steps past 1 and never lands on it, so the base case never fires. This is a genuinely unreachable base case, even with valid input. Here is the fix. It does two things and the order matters. First, reject invalid input. If n is negative, we return -1. We do not pretend a negative number has a factorial. Then the base case is n is equal to 0. Now every valid n, 0 or more, steps down and reaches it. Validate first, then use a base case the valid inputs can actually reach. So what does the broken version look like when you run it? Each call pushes one more frame with nothing to stop it. The stack grows until it hits its limit and the program crashes. That crash is called a stack overflow, and it often prints nothing useful. The crash also happens deep inside the runtime, far from the line that caused it. Picture two mirrors facing each other. Each one reflects the other, and the line of images runs on forever. A recursion with no reachable base case has the same shape. Each call starts the next one, and nothing stops the line. But here the picture breaks down. The mirrors cost nothing. Each call costs a real frame. So the machine runs out of stack and crashes. It does not loop forever. It dies at a finite depth. We already met the number one recursion bug, a base case that is never reached. Here are two more ways to break the contract. The first is putting the base case after the recursive call. If you check the base case too late, the check is never reached, and the function always calls itself again. The fix is to test the base case first, before any recursive call. The second way is passing the argument without shrinking it. If the argument does not move toward the base value, you make no progress. That is the same trouble as an unreachable base case. So check that the argument gets strictly smaller or strictly larger on every call. Let us read a small example of that first mistake. A student writes a function called bad. On this line, the recursive call runs first. It computes n times bad of n-1 before anything else happens. Only after that does the code check whether n is equal to 0. So the base case sits after the recursive call. Pause for a moment. What happens when this runs? Here is the answer. The function calls itself on every call before it ever checks and the base case can never stop it. So it recurses without end, and the program crashes with a stack overflow. It is the same failure as the missing base case bug, just from a different mistake.